Hello my dear students, welcome back to St. Joseph Composite PU College, Vijaypur. I am Rahul, chemistry faculty, and in this video I am going to discuss here factors affecting solubility of solute. Okay, this is very important. The concept is that we'll discuss in detail. There are various factors are there. The factors, let me list them. The first factor is nature of solute and solvent. Solute and solvent. This is important, students. Why it is important? Because the different nature of solute and solvents are there. What is the meaning of nature? We'll discuss that later. Let me have another the effect that factors affect the solubility of solute, particularly solid solute, that is temperature. Temperature. And third one is, you can say that pressure. Pressure. And these three things we're going to discuss one by one. Okay, so let me have the first one, that is the nature of solute and solvent. Nature of solute and solvent. Now the meaning of nature in this part is taken as, you can say that it is taken as the polarity. This is taken as polarity of a molecule. Polarity. So most of the students already know that what is the meaning of polarity. But even though, let me explain this for those students who don't know what is the polarity, how it created. For the polarity, we have to understand that there should be a bond between A and B. Now assuming that B is more electronegative, this is more electronegative. Electronegative. So already you know that what is the meaning of electronegativity. It is the capacity of atom to attract the shared pair of electrons. Now the shared pair of electrons should be near to the A and B, means both. They should be at the middle of the bond. But due to the B is more electronegative, these electrons reside near to the B. And by that, in this molecule, you can say that the electron density is more at the B, less at the A. Therefore, at the B, there is small negative charge is created, and at the A, a small positive charge is created. There is a separation of poles takes place, or separation of a small or fractional charges takes place, and that is known as a poles or polarity. That is known as a polarity in the molecule. So now there are two types of solutes are there. That is a polar solutes, non-polar solute. Again, solvents are also, you can divide into two types. One is polar solvent and non-polar solvent. And therefore what I will do that, I will divide the polar solute and polar solvent, how they interact with each other. If there is polar solute and polar solvent is present, polar solvent, there is always the formation of homogeneous solution. That is, solution is formed here. Solution. And for this we can take an example. Take container, and in that container fill with water, H2O, and you know that water molecule you can write in a different way like this. In this, the water molecule structure we have, that is, we have two bonds with oxygen, and oxygen is more electronegative, therefore it gains a negative charge, and hydrogen gains here positive charge. And this is a polar molecule. In the same way, in this I am going to add the salt, that is sodium chloride I am going to add, NaCl I am going to add, and Cl gains here negative charge and sodium gains here positive charge. These are the polar molecules. This is a solute and water molecule is a solvent. And this is an example we can get. Okay, so therefore example, we can provide example, that is sodium chloride, NaCl plus water we have to add. This is an example. The polar solute and polar solvent, that leads to the sodium chloride solution. Sodium chloride solution. Chloride solution is formed. Another possibility is that there is non-polar solute. I will take non-polar, that is solute, non-polar solute combined with polar, that is also, we'll take a non-polar solvent. In that case also we can get the same thing, right? It leads to the formation of solution. Okay, we can take an example. Take a container. We'll take an example here. So take a container, and in this container you have to fill with you can say that in this benzene you have to fill. It should be a benzene. It should be in the liquid form. Benzene you have to add in this, and the solute should be here, that is anthracene, or you can say that naphthalene you can use. Naphthalene Okay, the naphthalene is non-polar molecule, non-polar molecule, and that is dissolving in non-polar solvent, non-polar solvent. Okay, and this leads to the formation of solution. Solution is formed here. Okay, this is an example we can take. The naphthalene when dissolved in a benzene, this is a non-polar solute, and molecule is dissolved in a non-polar solvent. Okay, now the next part is that what happens if I put here polar solute plus non-polar solvent. In that you can see that there is no solution formation takes place. No homogeneous solution is formed. No homogeneous mixture is formed. Okay, means no solution formation. Okay, so vice versa also we can take a non-polar solute in polar solvent, then also there is no homogeneous mixture is formed or no solution is formed, and therefore we can make a statement here like dissolves like dissolves like, means polar dissolves in polar solvent, non-polar dissolves in non-polar solvent. This is all about the nature of the that is solute and solvent. The next part is about the temperature. Very important factor, temperature. Let's see temperature. Okay, in the temperature it depends upon the type of process like let me have some molecules. Okay, first let me take a container here. Okay, this is a container, and in this container I'm going to fill water. Okay, water is present, and what I'll do that in this I'm going to add the solutes like NaNO3, sodium nitrate I'm going to add, or I can add here KCl, or I can add here AgNO3, or I can add here NH4Cl. So when you add these all particles or individually particles or the solutes in the water, in the H2O that is acting here as a solvent, the heat, or you can say that the temperature of the solvent or temperature of the water becomes less, because the addition of these solute to the water is endothermic process. Okay, in that delta H solution is greater than 0. You have to remember this part. In the last year in the thermodynamics topics we have studied what is the enthalpy of solution. If the process is taking place with the absorption of heat, that is known as the enthalpy of solution is positive or greater than 0. And such conditions, for such you can say that scenario, if you increase the temperature, increasing temperature, then more amount of solute can be dissolved. Increase in the solubility. Increase in solubility. Solubility is increased here with rising the temperature, and therefore for the endothermic process, increase in temperature leads to the increase in the solubility. Let's understand what happens if I take another container and fill with some other solutes. Take a container, and this container you have to fill with again water. Okay, you have to fill with the water, H2O, and this is acting here as a solvent. This is solvent. Now what I'll do that in this, I'm going to add some of the solutes like lithium sulfate, that is Li2SO4 I can add. Okay, or Ce2SO4 thrice we can add, or we can add sodium carbonate, that is Na2CO3.H2O we can add in that. When you add these solute in a water, the heat is produced, and that process is known as exothermic process. And for the exothermic process, you have to remember the enthalpy of solution is less than 0. It means that it is negative. The liberation of heat takes place. In such cases, increase in temperature, you can see that you have to notice that when you add solute to the solvent, the heat is producing. You don't want a heat is producing, it giving away the heat. If you bring those all heat to the same container, the solubility should be decreased. Therefore, we can write here solubility decreases. So therefore, we can make a statement that for exothermic process, increase in temperature leads to the solubility decreases. To increase the solubility for the exothermic process, you have to decrease the temperature. You have to take out that heat energy from the container, which is liberated by dissolving this solute in a water. The whatever the heat is producing during this process, if you take it out, how you take it out? You have to take that container and keep in a lower temperature or in an ice bath, and by that what happens, the temperature is removed off, and by that the solubility increases. Okay, this is all about the you can say that temperature, but there is some molecules are there. If you take here, that is one molecule, that is Na2SO4 dot 10H2O. This molecule is very interesting, students. It varies solubility varies with the different temperatures. Like if I have a graph for this molecule, so let me have here. Okay, so how I get here the solubility, this is the temperature. Let me take a temperature coordinate, and this is solubility I will take on this side. So as you increase the solubility, as you increase the temperature, the solubility also increases, no doubt in that. But as you increase more temperature, the solubility becomes stable here, and later if you increase the temperature, the solubility decreases here. Okay, and where the temperature, where the solubility is changing, this is called as transition temperature. This is transition temperature. Okay, and this transition temperature for the sodium sulfate is about you can say that 32.8 degrees Celsius it is. Okay, transition temperature. So only simple thing is that we can say solubility of sodium sulfate increases with rising a temperature up to 32.8 degrees Celsius. After that it will decreases, solubility is decreased, and that we can predict this is due to the change of one solid form to, this is due to change of one solid form to another solid form. Okay, transition is taking place, the arrangement of atoms get changed there, another form, and because of that reason the solubility get changed in a water, right? So we can list out many molecules like that. Let's have one more, the last discussion, that is how the pressure is affecting, effect of pressure, the last part, pressure. That if I take here solid particles, you can see that solid particles are closely connected. These are the solid particles, these are very closely packed, there is no space. If you put a pressure on this, there is no compression takes place. Okay, and if you take this solid into a container, a closed container filled with the water, in that certain amount of water is present, let me take some water in this, water is present in this, in that case the solubility is not affected by increasing the temperature. So this is the only one reason that solids are unaffected by increase in pressure. So therefore we can write the effect of pressure on solubility, effect of pressure on solubility of solid in a liquid is negligible, it is neglected, neglected, student. Hope you understood this part. This is all about how the various effects, the factors affecting the solubility of a solid in a given solvent. Thank you for watching this video, students.